Hello friends, so today we are going to study about the preparation of alkanes. There are many ways to prepare alkanes, but we study about only some special cases, from which first is from, from unsaturated carbons. Unsaturated hydrocarbons. From unsaturated hydrocarbons. As we know, there are two types of unsaturated hydrocarbons. First is alkene and second one is alkyne. First is alkene and second one is alkyne. So how do we prepare alkane from alkene and alkyne? We prepare alkane from alkene and alkyne by the process of hydrogenation. Hydrogenation. What's the means of hydrogenation? Addition of hydrogen atom. Addition of hydrogen atom is known as hydrogenation. We add hydrogen atom to the alkene in the presence of palladium, platinum and nickel catalyst to form alkane, like alkene plus hydrogen, dihydrogen atom in the presence of palladium, platinum or nickel catalyst to obtain alkanes. Example: alkene CH2 double bond CH2 plus dihydrogen atom in the presence of platinum, palladium or nickel catalyst. We will obtain CH3 and CH3. This is ethene and this is ethane. And from alkyne, now from this was from the alkenes unsaturated hydrocarbon, and this is from alkyne unsaturated hydrocarbon, alkyne. Alkyne plus dihydrogen in the presence of palladium, platinum or nickel catalyst, we obtain firstly alkene. Then we will again do the same process as we perform the above. We obtain alkene here, so we will add dihydrogen atom in the presence of same catalyst, palladium, platinum or nickel. So here we will obtain alkene. Take also example of this. Example: this is CH triple bond CH plus this is ethyne. This is ethyne plus H2 in the presence of palladium, platinum or nickel catalyst. We will obtain firstly ethene, CH2 double bond CH2, and again there will be the hydrogenation process in the presence of palladium, platinum or nickel plus H2. Here we will again add dihydrogen atom, so we will obtain CH3. This was the first from the preparation of alkane from unsaturated hydrocarbon, and this is a type of exothermic reaction. Here heat is evaluated in this reaction. Now the second process is from alkyl halides. How we can prepare alkane from alkyl halides? We take alkyl halide CH3Cl. This is the alkyl group and this is a halogen. A compound composed of alkyl and halogen is known as alkyl halide plus S2 in the presence of zinc catalyst. Alkyl halides plus dihydrogen in the presence of zinc catalyst give out a alkane CH4 plus HCl. Here is two atoms of hydrogen, so one will attach with the this compound and one will attach to the this compound. This is let's check the mechanism of this reaction. CH3 and this alkyl halide will break into CH3 plus and Cl minus, and this dihydrogen atom will be H plus H. One hydrogen atom will go with this and one with this, so this will be CH4 CH. This will be CH4 and this Cl will be attached to this hydrogen atom and this will become HCl. And now take another example of this. We take ethyl C2H5 chloroethyl. This is chloroethyl. We will add dihydrogen atom in it in the presence of zinc catalyst. Then this will form C2H6 plus HCl. This is the mechanism of preparation of alkanes from alkyl halides. But there is an exception. Here at the place of Cl there should be any halogen except exception is fluorine. Exception is fluorine. Why? We will also understood why fluorine is not taken in this reaction, because fluorine is very electronegative, so it will make a very strong bond with C2H5, like not C2H5, any alkyl group. Fluorine will form very strong bond with the alkyl group, so we take C2H5 fluorine and S2, so Zn plus H plus. This is the catalyst used in this reaction. So this will not reduce to the any product. This reaction will not happen because the fluorine is more electronegative to the hydrogen, and fluorine is also very reactive in the comparison of hydrogen atom. So this will not leave there will be no displacement reaction, because here the displacement reaction occurs. Hydrogen will attach to the C2H5 and HCl will attach to the another part of the hydrogen atom. So here double displacement not occurs, so this will not form any product. So this is exception in the alkyl halides. Fluorine does not reduce to form alkanes. Its reason is that carbon fluorine bond is strong, that the bond between the carbon and the fluorine is very strong, so it not reduces. Now we will see the preparation of alkanes from alkyl halides from Woods reaction. So in the Woods reaction, alkyl halides on treatment with sodium metal in anhydrous solution of ether gives higher alkanes. So we treat alkyl halides with the sodium metal in the presence of anhydrous ether. We will saw the reaction here. So here we take two compounds of alkyl halides like CS3Cl plus 2Na plus CS3Cl. One compound is this and another is this CS3Cl. We take two compounds on treatment with dry ether. On treatment with the dry ether, the output is CS3 plus 2NaCl. This Cl and this Cl remove from these both compounds and attach to this sodium metal. So these alkyl groups attach to each other and they form an alkane. So this is ethane and NaCl is formed. We take here dry ether. Why should we take here dry ether? Why we should not take here hydrated ether or ether in which the water is present? So in this whole process an intermediate is formed. Which is hydrogen. An intermediate is formed which is not hydrogen, that is free radical, which is very reactive with H plus. And if we take hydrated ether, then there will be water atoms will be present, and water means H2O. This is H plus OH minus. This is H2O. So this H plus will very easily react with the free radical and the alkane is not formed here. So the unwanted output will come here. But we want alkane, so we will take dry ether. So we will take another example for the Woods reaction. C2H5Cl plus 2Na plus C2H5Cl in the presence of dry ether gives 2 C2H5 means C4H10 plus 2 NaCl. Here C4H10 will be formed and the 2 NaCl will be also formed here. And here the compound will be formed by Woods reaction. Always contain even number of carbon atoms. Here the compound will be formed by the Woods reaction always contain even number of atoms. As we can see here the examples. Here this compound is formed by the Woods reaction and this has two carbon atoms and 2 is odd. Here C2H6 is formed here. This is C2H6. So C2H6 is formed here and there are 2 number of carbon atoms and 2 is even. And even in this example also there are 4 carbon atoms and 4 is also even. So with the help of Woods reaction we can form only the compounds containing the even number of carbon atoms. Now the next process for the formation of alkanes is from carboxylic acids. So first process is decarboxylation and the second is Kolb's electrolytic method. So firstly we will understand what is decarboxylation. Removal of CO2, removal of carbon dioxide to a compound, to or from a compound, from a compound. Removal of CO2 from a compound is known as decarboxylation. And now we will see the whole process about the formation of alkane from the decarboxylation process. So we take the sodium salt of carboxylic acid. This is the COO minus and the Na plus. This is the sodium salt of carboxylic acid. We have already studied it in the earlier class 10th. And we take soda lime NaOH plus CaO. This forms soda lime. Sodium salt of carboxylic acid on treating with soda lime gives alkanes with the some another outputs. So we take example RCOO minus Na plus soda lime NaOH in the presence of CaO. This is R. Here R is alkyl group and COO. This is the COONA. This whole is the sodium salt of carboxylic acid with alkyl group. On treating with this whole is soda lime. This will gives RH plus Na2CO3. Now take example like CS3COONA plus NaOH. This whole is soda lime. So this will give CH4 plus Na2CO3. Here the alkane is formed by the process of decarboxylation. Now we will see the Kolb's electrolytic method. This is also very important reaction. Kolb's electrolytic method to prepare alkanes. Here we take a aqueous solution of sodium or potassium salt of carboxylic acid. We take a sodium or potassium salt of carboxylic acid RCOO minus Na plus or RCOO minus plus K plus. We take anyone from this, anyone's aqueous solution from this aqueous solution. So we take two compounds of anyone from them. We take 2 RCOO Na plus 2H2O. We have to take aqueous solution, so we will add water to in this, so this will become an aqueous solution. Then this will form CH3 plus 2CO2 plus 2K2NaOH plus S2.